My name is Rick Himes. I'm a technical executive within the environmental controls area of the generation sector of EPRI, and been involved with EPRI for the last 25 years, and prior to that 17 years as a consultant in the utility power industry with a focus on boiler performance and emissions control. Over the last 4 years, I've been a program leader of our continuous emissions monitoring and measurement program, of which we've been focusing on the technical side on the use of in situ optical monitoring technology in a continuous emissions monitoring capacity. This has presented a number of technical issues and questions that we've been resolving item by item through sequential demonstration projects with vendors such as ESC Spectrum and others. So we've been addressing the challenges item by item, and we are currently conducting our third demonstration project, but let me take a step back and review where we've been, because that helps understand the focus of where we're at right now. Our first project was on the stack of a gas turbine combined cycle, and where we applied a multiple number of in situ optical monitors to demonstrate the performance and accuracy of this measurement technology. And we looked at things such as ultraviolet digital optical absorption spectroscopy, or UV-DOAS for short, to measure NO, NO2, and ammonia. We also looked at near-infrared laser technology to measure O2, CO2 as the diluents, CO, and ammonia, as well as moisture. And that project by itself demonstrated that this technology had the performance characteristics that could be used in a CEM capacity. Two issues that came out of that project, however, were the fact that the monitors needed to be located at that point in time up on the stack, which had limited physical access. Secondarily, there was also an issue associated with the application of Part 75 QA/QC requirements for daily calibrations and linearity testing. So that was one of those items was the focus of the second demonstration project that we just completed last year, where we demonstrated the ability of transmitting the light sources over a nominal 25-meter path. Why is that important? It allowed us to locate the monitors down at grade elevation while transmitting across the entire optical path of the duct entering the stack. So that addressed the issue of, do we need to put the monitors on the stack if they need to be located close to the ports? No, we can put them at grade and transmit over long distances. And the project that we're doing this year is we're working with a multiple number of vendors, and this is the most important piece. We're addressing the Part 75 QA/QC requirements. And why is that important? The EPA wants us to challenge the entire optical path. And to do that, we have to have an inline calibration cell to create what's termed a dynamic spike. But that has to be scaled based on the relative difference of the calibration cell path length and the measurement path length. And that requires a much higher concentration of reference gas than typically used in an extractive monitoring approach. So the projects that we're doing this year will be demonstrating some new innovative approaches that reduce the concentration of these reference gases. and make them more viable and potentially set this technology up to be used in a CEM capacity.